Hi, good afternoon, everyone. What we are going to go ahead and do today is to look at the past year paper of Intermediate Microeconomics 2022, right? So this is one of the questions that came in Intermediate Microeconomics, Delhi University 2022 paper, Microeconomics-II. Okay. So, so before I start, I would like to highlight that you can go ahead and download our app, Artha Point, on the Play Store, and you will get access to free course of semester 4 Delhi University, Econometrics. So you will get this absolutely free of cost. You can go through it before your final exams. Apart from this, the solution of what I'm going to do today is also going to be available in the written format on this app, right? So you can go ahead and have a look at that written solution also from our app. You can download that app and have a look at it. Okay, so without further ado, let us go ahead and begin with the first question. So this is the first question that came in the exam, and the question says the following. It says, suppose there are two consumers, A and B, who consume two goods, X and Y, in a pure exchange economy. Their utility function, UA, so the utility function of individual A, that is given by 2XA plus YA. Get some lines here. So it is given by 2XA plus YA. Okay. And the utility function of individual B is given by XBY. It is given by XB, YB. Okay. Second, this will be XA, YA. Okay. So this says, if the initial endowment of the two goods are, so EA, endowment of individual A, is given by 2 units of X and 10 units of Y. So it is going to be 2, 10. And that of individual B is given by 8, 10. So endowment of individual B, that is given by 8, 10. So this, if I have to find out the dimensions of the Edgeworth box, is going to be 10, 20. See, examiner, because I myself have taught in Delhi University for a long time, and I've gone for paper checking. So from my personal experience, I am telling you that the more neat that you write, the more clean answers that you write, and the more you write about something, the more the marks you will fetch, right? So for example, in this case, if you go ahead and you mention that, if you go ahead and you tell that, okay, in order to find something like this, so please see how I will write the complete answer today. You have to make a note of it. So you have to write something like this: in order to find the dimension of the Edgeworth box, we can add the endowment bundle of the two individuals. I am telling you, every day multiple papers have to be checked. And since multiple papers have to be checked, I have, as an individual, we have very less time to check per paper. It's a hurry. I don't have time for it, right? So the more neat you write and the more easy things are while I read your paper, the more better it is going to be. This is part A. I have to mention those things, right? Okay, so the endowment adds up to 10, 20. So we will make this Edgeworth box now. Please carry a scale. I don't have one right now, so I'm going to just draw an Edgeworth box. So you have to understand that the length and breadth are not symmetric. This is not a square Edgeworth box. It is a rectangular Edgeworth box. This is OA. This is OB. है ना बेटा? So now we have to start marking. So 2, 4, 6, 8, 10, 12, 14, 16. Oh, good luck. 18 and 20. 2, 4, 6, 8, 10. Let's just draw this at 10 only. Let this be 10. You have a scale, right? You have to draw it in a better way. So this is origin of individual A. Now you don't end it here. You also draw the origin of individual B. So OB. Okay. This is origin of individual B. And you will mark the other points subsequently. So against 8 here, you should have 2. Against 6 here, you should have 4. Against 4 here, you should have 6. Against 2 here, you should have 8. And then this becomes 10 for individual B. Similarly, against 18, you will have 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. This is your Edgeworth box. Now it tells you to mark the initial endowment point in an Edgeworth box. So if I mark the endowment of individual A, it means automatically the endowment of individual B would be marked, right? So I need to go ahead and mark the endowment bundle of individual A, which is 2, 10. So 2 units here and 10 units here, which means this. This is my endowment bundle, omega. If I see here, this automatically means that 8 units is consumed by individual B and the remaining 10 units are consumed by individual B. Remember, my budget line has to pass through the endowment bundle always, right? Because I can always consume my endowment, right? So my income can always afford the initial endowment bundle, right? So that should be affordable. Okay, so now let's go one step ahead and go to the part B of this question. So the second part then says, so this is my first part, beta. The second part says derive the consumption contract curve and plot it. Now, part B. Please write down. The consumption contract curve is the locus of all Pareto efficient points that can be consumed by the consumer. So ideally, I just need locus of all Pareto efficient points. Now, in order to draw the Pareto efficient points, I need to go ahead and I need to find out how the ICs of individual look. So what I'm going to go ahead and do is the following, beta. Let's just take this Edgeworth box for a second. Make sure that you draw them again, okay? In exam. Right. So now I need to go ahead and I need to somehow draw the ICs of the two individuals. it will be a good idea in exam if you can draw the ICs with different color, one with a blue pen and one with a black pen, just to be sure that you are able to distinguish between the two in different forms. For individual A, he has substitute goods, right? So the utility function of individual A is given to me as 2xa plus ya. So his MRS that I have of individual A, that will be mux by muy. You have to write all this down for good mark. So if I differentiate this with respect to x, I get 2. With respect to y, I get 1. Therefore, I know that the MRS of individual A, that is going to be 2 by 1, which is going to be 2. So the MRS of individual A is 2. MRS is the slope of the IC. So slope is 2. So perpendicular by base, that is 2, right? So when perpendicular is 4, base should be 2. तभी तो ratio 2 आएगा. Perpendicular 4 हुआ अगर, just think about it. And base 2 हुआ, so 4 by 2 is 2. So which means that if I were to draw this IC, my indifference curve would have looked something like this. My IC would have looked something like this. This would have been the IC of individual A, right? Acha, इसी को you have to continue. So if it is 8 here, it will be 4 here. Of course, I don't have a scale. If it is 12 here, it will be 6 here. These are the ICs of individual A. Now let's talk about the IC of individual B. So utility function is given by XB, YB. So if I find out the MRS of individual B, it is going to be MUX upon MUY. If I differentiate this with respect to X, I will get Y. And with respect to Y, I will get X. So this is the MRS of individual B. Now just think about it. If I were to hold the utility of individual B constant, suppose at 4. So what are the different combinations of X and Y that can give me 4 beta? If X is 1, then 1 into 4 is 4. If X is 2, then 2 into 2 is 4. If X is 4, then 4 into 1 is 4. So which means that if I were to go ahead and do this point, 2, 2, 4, 1, which means this point, half of this, and 4, 1, which means, excuse me, sorry, this point, right? This is the worst Mausam in Delhi. Sometimes you go from AC towards heat and heat to AC, and all you do is sneeze. This is going to be the IC of individual B, right? So these are these rectangular hyperbola kind of things, right? A well-defined IC, right? So now the question is, how do we find Pareto efficient points? So for finding Pareto efficiency, you go ahead and you ask which is the highest bundle or highest IC that A can reach given the IC of B. That's one way of asking Pareto efficiency, right? So given, so you know, now you can just draw a general one. I just wanted to show you here how to draw it. But if this is the IC of individual B, I want to ask what is the highest IC that A can reach, right? So, you know, I keep going ahead with A. And what you will observe is that that will happen at the point of tangency. That will happen at the point of tangency. This is the highest IC A can reach given the IC of B. So this happens at the point of tangency. I'll give you a very interesting, story here. So when we were in college, when I was in Delhi University, my first semester, we had 3 subjects, right? Introductory, micro, macro, and math. And I think so. It was the first time that Delhi University had gone from its annual system towards the semester system, right? So when we gave our exams and the result came, um, you know, I had scored a full 75 in all 3 subjects. And when my father, he was going ahead and he was looking at my marks, he kind of opened my result. He was very surprised. So he said, I think they made a mistake and they have gone ahead and they have given the maximum marks instead of giving your actual marks, right? That's the kind of thing that happened in Delhi University, right? So if you are thorough with what you write, you can score a full 75. And this is the way I used to answer my questions in exam. I have never gone ahead and missed a single point in writing an answer. So if you ask me about my contract curve equation, I will make sure that I tell the examiner that I know Pareto efficiency, that I know the definition of contract curve, right? And I can tell you the same Pareto efficiency using 5 different ways. I could have gone ahead and told you that here there is a mutual area which is being created, mutually common area where both of them can go ahead and improve, mutual improvement area. So as long as you create a gap between 2 ICs, you never reach a Pareto efficient point. It happened at the point of tangency. So you have to be thorough enough with what you write, and you have to mention and underline and write it in good language so that the examiner has no reason why the examiner would cut marks, right? Okay, so coming back to this then. So we have seen that it happens at the point of tangency. Therefore, for equilibrium, we require, because tangency requires the MRS to be equal, this is what we have. So the MRS of individual A was 2 and B was YB by XB, right? So from here, the equation of the contract curve is this. This is in terms of B beta, okay? At any point of time, if you require, you can also convert this in terms of individual A. How? I know that the total X that is available in the economy is 10. And the total Y that is available in the economy is 20. So I can say 10 minus X8 is equal to 20 minus YA. So it will be 20 minus 2XA is equal to 20 minus YA. So this is going to be 2XA is equal to YA. So this is the contract curve in terms of individual A. Now, why I did it in terms of individual A? Because I want to plot this contract curve. And plotting is easier when I check it from the origin of individual A, right? So what I can do is, if I were to just go ahead and paste this here, the same the same diagram that we had drawn, I now know the equation of my contract curve. And the equation is that YA is 2 times XA. So when XA is 2, YA will be 4. When XA is 4, YA will be 8. When XA is 6, YA will be 2 times, which means 12. When XA is 10, YA will be 20. So the curve, the line is going to be this. This is my contract curve because they've asked me to plot it. And this equation that it satisfies is 2XA is equal to YA, or XA is YA by 2. This is the equation. Now, this means that at any point, if I were to draw an IC of individual A, So, if I were to go ahead and draw, this is the IC of individual A, right? Iska MRS 2 है, perpendicular 6 है, base 3 है. So if this is the IC of individual A, then the highest IC individual B will attain will be at the point of tangency here. And we have gone ahead and we have marked all such points. Agar ye IC of individual A hai, then this is going to be IC of individual B, and this will be my Pareto efficient point E dash. So joining all such Pareto efficient points, I have been able to get my contract curve. Okay. Okay. So this is my part 2 of the question. Derive the consumption contract curve and plot it. Okay. Now come to the third part. Find the competitive equilibrium allocation and the price ratio. Okay, this is interesting and a little difficult. Why? Because this is not a square Edgeworth box, right? Anyways, so you have to show all the steps. So let's begin. Part 3. So in this, what we can do is we can take different ratios of the prices. The reason being that individual one has substitute code. So please write down. For individual one, he has substitute good. So utility of individual A is 2xa plus ya. This is how the utility function can be written. Now, this means that we have already found out that his MRS will be MUX by MUY, which will be 2 by 1. So case 1 that I'm going to take, it will be if MRS of individual A is greater than the price ratio. So MRS of individual A is 2. So 2 is greater than PX by PY. Right? This implies that whenever MRS is greater than the price, you consume only good X. So individual A will consume only good X. Okay. अच्छा, अगर इंडिविजुअल ए सिर्फ गुड एक्स कंज्यूम कर रहा है बेटा, हाउ मच एक्स कैन ही कंज्यूम? His X consumption will be MA by PX. His endowment bundle was 2,10. Right? So income of individual A will be 2. He's consuming 2. He had, but when he started in his going to the market, he had 2 units of good X. So it is going to be 2 PX plus 10 PY. This is his income. He's consuming only good X. So XA will be 2 PX plus 10 PY upon PX. So this is going to be 2 plus 5 PY by PX. Now come to the demand by individual B. If you have done things thoroughly, by now you would know that if you have a Cobb-Douglas production function, नहीं भी किया है तो अभी के लिए just understand this thing. Derivation की जरूरत नहीं है. That whenever you have a Cobb-Douglas well-defined production function, then the demand of X and Y is given by alpha upon alpha plus beta M by PX, and Y is given by beta upon alpha plus beta M by PY. So if alpha यहाँ पे 1 है बेटा, beta भी 1 है, power is alphas and betas. So XB will be alpha upon alpha plus beta, income of individual B upon price of good X. So half income of individual B upon price of good X. Now, now income of individual B. This is given by the endowment bundle only. So his endowment bundle was 8, 10, right? So it will be 8 px plus 10 py, right? So how much x will he consume? Alpha upon alpha plus beta income by price of good x. So if you solve this, you will get 4 px plus 5 py upon px. This will be 4 plus 5 py by px. So we have got what individual A will demand and what individual B will demand. Now what can we do? We can add the two together. So for markets to clear, competitive equilibrium kya hota hai? That markets should clear. We want that demand of X should be equal to supply of X. Kitna X available hai total? 10 units. Edgeworth box ka dimension was 10. So I have 10 units of good X available. How much is individual A demanding? Individual A is demanding 2 plus 5 py by px. So 2 plus 5 py by px. And how much is X demanding, beta? Achha, many people do it by the concept of numeraire price. If you want, you can use it. Otherwise, no need. It's okay. So, oh God. Let me just take a moment, please. I think I should be on the same screen now. Okay, let's go back to the question. So how much is individual B demanding? B is demanding 4 plus 5 py by px. So 4 plus 5 py by px. This is 10, right? So I get 5 plus 2, 9, right? Plus, sorry, I get 4 plus 2, 6. So I get here 10 py by px is equal to 10 minus 6. So 10 py by px is equal to 4. So 10 py is equal to 4 px. So px by py will come down to 10 by 4, which will be 2.5. We will get px by py as 2.5. Tell me something. Didn't we assume that px by py is less than 2? We did. We assumed that px by py is less than 2. And now we are getting an equilibrium that px by py is 2.25, 2.5. This is a contradiction. So we can say that this is a contradiction. Therefore, px by py less than 2 cannot be competitive equilibrium. Now let's do the other case. So case 2. Okay. And in case 2, we are going to go ahead and take px by py greater than 2. But if px by py is greater than 2, then consumer A will consume only good Y. So demand of good X by A will be 0. And demand of good X by B, I have already found out. It is given by M by 2px. We did this now. And this value beta we had found out as 4 plus 5 py by px. So it is going to be 4 plus 5 py by px. So we know that for competitive equilibrium, market should clear. So I need XA plus XB should be equal to 10. So I need 0 plus 4 plus 5 py by px should be 10. So I have 5 py by px as 6. So I have px by py should be 5 by 6. So we have got that px by py will be 5 by 6. But this is clearly less than 2. But we started our assumption by saying that px by py should be greater than 2. Therefore, we have reached a contradiction. Therefore, px by py greater than 2 cannot be Nash equilibrium. Oh, sorry, cannot be competitive equilibrium. Okay. Now let's come to the third case. Case 3. Beta, case 3 में directly भी कर सकती थी. Substitute good में I could have done this directly. With practice, you should know that this will be the only equilibrium. But in exam, it is a good idea to show all the cases. So px by py is exactly 2. Therefore, consumer A will consume. बेटा अगर प्राइस रेशियो और MRS इक्वल होते हैं, so how much will A consume? So demand of individual A will be anything between 0 to the maximum amount. Anything between 0 to maximum. कुछ भी हो सकता है. And individual B की demand तो मुझे पता ही है. I have just written it above also. B की तो सेम ही रहेगी ना. B तो कॉप डॉगलेस है, उसको प्राइस रेशियो से फर्क नहीं पड़ रहा. He will always consume 4 plus 5 py by px. So 4 plus 5 py by px. फिर से let's just equate demand plus supply. Demand of A plus B equal to supply. So यहाँ पे हम dash छोड़ देते हैं अभी. It can be anything between 0 to this plus 4 plus 5 py by px is equal to xs. The total demand supply of good x is 10. So I will get dash plus 5 py by px is equal to 6. So we have assumed that px by py is 2. यही तो मैंने केस लिया है. ऊपर I couldn't do this because I just said less than 2 or greater than 2. I didn't have a number in hand. But in case 3, I have assumed that px by py is 2. So if it is 2 beta, then py by px will be its reciprocal half. So I can write half here. So it is going to be dash plus 5 into half as 6. So I will get dash plus 2.5 is 6. So I will get this amount that A consumes will be 6 minus 2.5, which will be 3.5. Now listen to me very carefully. देखो एक क्वेश्चन से पूरा general equilibrium revise हो गया है. We have done the entire general equilibrium. We don't have to do anything else in this chapter after this. Listen to me. I am getting that the amount of good X that A consumes is 3.5, right? Acha beta, what is the income of individual A? Income of individual A was MA which was nothing but he had 2 units of good X, 10 of good Y. So 2px plus 10py. यही तो था. If I assume that the price ratio is 2, एक बारी समझ लो ध्यान से, तो can I take px as 2 and py as 1? I can. So based on that, from here, I will get 2 into 2 plus 10 into 1. This means I will get 4 plus 10, which means I will get 14. 14 rupees is what I have. But I have consumed 3.5 units of good X. And each unit of good X, so my budget line is this only, na, 2px plus 1py, क्योंकि price ratio 2 और 1 है. So 2px plus 1py, sorry, 2x plus 1y is equal to income of the consumer. यही budget line है. Price is 2, 1. I can consume X units of good X and Y units of good Y. So the price ratio is this. This is my budget line. बेटा income मैंने 14 निकाली है. Good X 3.5 units है. Good Y मुझे पता नहीं. So 7 plus Y is 14. So Y should be 7. If I consume 7 units of good Y, then I am on my budget line. Everything is clearing for me. My market is clearing. I am spending my entire income. This will be a check. If I get good Y's demand as exact 7 units, I'm done. Let's just solve this and check. So let's check for good Y also. Good X का तो clear हो गई है market, क्योंकि total demand plus supply, जितना demand X का ये कर रही है, individual A plus B, it is clearing the market. So from here we know that individual A is demanding 3.5 units and individual B is demanding 6.5 units. This is clear to us, right? And you can check from here also, na beta. So this is half. Py by Px is half. So 5 into half is 2.5 plus 4. This is what individual B is demanding. So individual B is demanding 6.5 units and A is demanding 3.5 units. So we have got that market of good X is clearing. But if I want to check for good Y also, it's not required in exam. Yahan pe bhi you can just say that this is equilibrium. But if I need to check beta, then I need YA plus YB should be equal to supply, which is 20. Because price ratio is equal to MRS for individual A, he can consume any amount between 0 to maximum. Individual B will consume his income upon 2py equal to 20. Income of individual B was beta, his endowment bundle was 8, 10. So 8px plus 10py upon 2py is equal to 20. This is what A will consume, right? So this is going to give you plus 4 px by py plus 10 is equal to 20. Why? But px by py is 2. So I will get 4 into px by py is 2 plus 5 हो जाएगा ना, plus ya is equal to 20. So ya plus 13 is equal to 20. So individual B will consume 13 units of good Y. How much can A consume? A can consume 20 minus 13, which is 7 units. Yehi to tha upar. This is exactly what I was getting. That in order to be on the budget line, he needs to consume 7 units. So we have got our competitive equilibrium. So the competitive equilibrium is when individual A is consuming 3.5 units of good X, 7 units of good Y. And B is consuming how much beta? B was consuming 6.5 units of good X and 13 units of good Y. And the price ratio that I have got is 2. This is my competitive equilibrium. Good question. Very good. Because all concepts have been thoroughly revised. Okay, last one. It says verify if competitive equilibrium is fair allocation or not. Okay, let's write down the answer to that. So please write down. An allocation is fair. कब होती है fair बेटा? If utility, I'm just writing it in my own language, that consumer gets from his own bundle is more than the utility he gets from other bundles, from others bundle. So what utility individual A gets from his bundle, it should be more than what individual A gets from B's bundle. So in order to write this, I can say here XA, YA, XB, YB. If I get more utility from my own bundle rather than your bundle, then I am having a fair allocation. I don't envy you, right? I'm not envious of you, right? So beta, just think about this. I am already given the utility functions of the individuals. So if I were to go ahead and I were to go ahead and I were to find what utility these individuals get from their bundles and whether it is more or less as compared to others' bundle, I am done. I just have to check whether the individuals are envious or not, right? If you go back, just some knowledge here. If you go back to your variant book, I think so it is chapter number 33 of the old book, you will have this complete chapter that talks about when is an individual envious or not, right? What is the concept of fair allocation, right? What is the concept of equity, right? So you can go ahead and read that chapter to understand more about this concept. Okay, so never mind. Let's now just jump into this question. So tell me something. What is the utility function of individual A? Utility function of individual A is 2xa plus y. So if I want to check the concept of fair, I can say it has to be envy free. So I want that 2xa plus, this should be ya, should be greater than 2xb y. In my utility function, if you go ahead and you put the bundle of individual B in my utility function, then I have to check what utilities the two individuals are getting. Okay, so very well. So now let's go ahead and find that out. So when I find out the utility of individual A from his own bundle, this is the definition. When I put his own bundle, what will I get? I will get 3.5 plus he's consuming 7 units of the other good plus 7, and this is 3.5 into 2. 2xa plus ya. This will be 14. Okay. And when I put utility of individual A through xb yb, this is going to be 2 into 6.5, 13 plus 13, which will be 20. तो बेटा ये डेफिनेशन तो फुलफिल नहीं हो रही है. I am getting more utility. I am getting more utility from your bundle. So I envy you. I want your bundle. Is this making sense? So the definition is not being satisfied. So A is envious of B. Now let's check for B beta. वैसे यहीं पे हम बता सकते हैं it is not fair. But let's check for B also. Suppose in exam now they just ask about whether A is envious of B, whether B is envious of A. ऐसा कुछ पूछ. So individual B's utility from A's bundle. His utility function was XBYB. So it will be 3.5 into 7. This will be 24.5. And his utility from 6.5, 13. This is going to be 6.5 into 13. This is going to be 84.5. Clearly, he gets more utility from his bundle over the utility from individual A's bundle. He does not envy. He prefers his bundle. But for fair, we have to check both sides. And for A, the definition is not being met. So therefore, it is not envy-free. Therefore, not fair. Take a bit. This completes the complete question number 1, part A. Let me take part B also with you. Okay. A housing developer wants, let us have some lines here. A housing developer wants to build houses on a piece of land located next to an airport. However, the noise pollution, question on externality, from planes that lands at the airport reduces the value of houses and hence the profit of the developer. If X denotes the number of planes that fly per day, so X is number of planes that fly per day, right? And Y be the number of houses developer builds. Y is number of houses developer builds. Okay. And you're given profits. If no bargain can be struck between airport and developer, okay, and each can decide its own level of activity. So we are saying that there is no bargain that can be done. So you have to maximize your own profits. How many planes will fly to maximize profit of airport? Okay, so first case. I am doing it from the point of view of the airport. So the profit function beta given of airport is 56x minus x square. So pi a will be 56x minus x square. I will differentiate this with respect to x. I will get 56 minus 2x. I will equate it to 0. X star will be 56 by 2, which will be 28. Nobody does this, but I kind of want to do this completely. So it is minus 2 less than 0, therefore maximum. Kar liya karo, second order condition. So I attain the maxima at x star at 28. Then it says that what is the maximum profit? So x star ko dal do. So pi a at x star equal to 26 will be, what is your function? 56x minus x square. This will be simply x ki value 28 thi na? So 56, this is just 28 into 28, 28 square only, right? So 28 square is 784, right? Okay. Just check this, huh? So second part. Okay, so the second part says, given x star planes fly, how many houses will be built to maximize profit of the developer. So the developer's equation beta, the profit of the developer is given by 70y minus y square minus xy. 70y minus y square minus xy. So it is given, you have to take x at 28. This is what it says. So this is going to be 70y minus y square minus 28y. Now the developer will maximize his own profit. Right? So we know that d by d by dy will be 70 minus 2y minus 28 equal to 0. This is how the developer will maximize his profit. So 2y will be 70 minus 28 to 42. So y star will be 21. Then he says, find the maximum profit of the house developer. Very simple. So maximum profit of the developer. यहाँ पे भी second order कर लेना, -2 आएगा यार. Do that. Okay. Del square pi d by del y square will be -2 less than 0. So maximum. Achha. So now I want to have x star at 28 and y star at 21. What will be his profit? His profit will be 70y. 70y minus y square minus 28y. So if I take 21 common, 70 minus 21 minus 28, 191, 2 to 4, 21 square हो गया बेटा ये 441. Okay, so the profit will be 441. Okay, let's come to the third part. So this says now, suppose that the local ordinance make it illegal to land planes at the airport. So now you cannot have planes anymore. You cannot land planes at the airport because they impose externality on the developer. Find optimum number of houses that will be built and profit. Very good. So if it is illegal to land planes and no planes can be landed, so matlab x ho gaya beta 0. No planes can be landed. So the profit function was 70y minus y square minus xy. X 0 ho chuka hai. So 70y minus y square minus 0. So 70y minus y square. This is the profit function of the developer. He wants to maximize his profit. So d pi d by dy will be 70 minus 2y. He will equate it to 0. So y star will be 35. Please double derivative भी कर ही लेना. So dy square minus 2 less than 0. Therefore maximum. Okay. Now, what is the maximum profit that he will have? So profit at y star 35 and x star 0. What will be the profit? 70 into 35 minus 35 square minus 0. So ये तो 35 square ही हो गया सीधा. 35 square is 1225. That's your answer. Okay, let's go to the last part of this question. It says, suppose there is no ban on plane landing, but a single firm has bought it. How many planes will be flown and houses built to maximize joint profit? So now we have to maximize the joint profit. ठीक है जी. So joint profit will be pi. So this will be pi of airport plus pi of developer. Airport का था 56x minus x square है ना, और developer को क्या था 70x minus x square minus x, sorry 70y minus y square minus xy. Okay. This is the joint profit. So two things I have to now ask. I'm just a single firm. I have to ask one, how many airports, how many planes should I fly, and how many housing should I develop? So del pi by del x. ये हो जाएगा 56 minus 2x minus y equal to 0. This is equation 1. Del pi by del y. This will be 70 minus 2y minus x is equal to 0. Equation 2. So solving equation 1 and 2 simultaneously. Right? So you will get 56 minus 2x is y and 70 minus x is 2y. So from here, you can use the method of substitution or Kramer's rule, jo use karna hai karo. So I will use the method of substitution. 70 minus x is equal to 2 and y ki jagah pe I will write 56 minus 2x. So 70 minus x is equal to 112 minus 4x. 3x is equal to 42. X star will be 21. 3 hai na? X star will be 14. And y star, it is 56 minus 2x. So 56 minus 28, which also will be 28. So I will have 14, 28. Acha, have they asked us to find maximum profit also in this case? No. They've just asked us if there is single firm, then how many planes will be flown and houses built to maximize joint profit. So you will be building 14 planes and 28 houses to maximize joint profit. But this completes question 1 of the past year of 2022 intermediate micro part 2 paper. Okay. You're supposed to go ahead and at least do all past years before you sit for your exam. Over the next few sessions, even I will be going ahead and solving some more questions with you. Okay, you can always download our app and have an access to free course for semester 4. Okay, thank you. Thank you, students. Bye.